Good morning. Thanks very much for attending. My name is Kevin Kostrzewa, and I'm a software engineer with Thomson Reuters, along with my colleague John Wyman. We both have an affinity for C++, and especially modern C++, having programmed in C++ since the early 1990s. There is a necessity for any multi-developer project to have technical leadership set a development culture. It's tough to find metrics on this. Static analysis can't be done on culture. What we try to do is find things that work for our group and our situation. If they work, we keep doing them. If they don't, we don't. In some ways, it's as simple as that. Some of the things that we talk about today may work for your situation, some may not. We like to take our energy and provide leadership back to our organization around C++, which we'll talk a little bit about today. I should note that there really won't be much around code examples. This is not about nuances in language and specific advances in modern C++. It's more about ways that we communicate modern C++ to our developers in the interest of keeping them current, engaged, and generating quality code. The Standards Committee has modernized C++. Every iteration increases the language's capabilities, but it also increases the overhead of keeping a development staff current. It outdates prior approaches to problems. For example, old idioms around not returning large objects compared with move semantics allowing greater penalty-free compositions of expressions. The good news is changes from the Standards Committee are improvements. They either help to produce more durable, efficient, or easier written code. Also, the Standards Committee is kind enough to not break our code with these changes. The challenge is that technical leadership's responsibility to help modernize our development organization so we can reap the performance, readability, and resilience benefits that come with. For us, no matter how good of developers we try to be, we represent less than 4% of our code churn, and we like that other 96% to be high quality. We're presenting this as a case study. This is our development organization and our culture. There are two important pieces to understanding the context of where we're at: the history of our application combined with the history of C++. The former may or may not overlap with your development situation, but obviously the latter is shared. Now, some background on us, our context. We currently develop a business application in C++ for Microsoft Windows, which was started in C on MS-DOS, currently developed on a Microsoft stack, the whole thing. We're using Visual Studio, TFS. We run on Windows Desktop. We have about 75 developers, and about 175 total development staff with about 11 million lines of code. And we're developed out of Ann Arbor, Michigan, which is a great developer community, but not quite coastal. Combine that with information that most of you already know, where C++ keeps changing on a more and more accelerated timeline from 1983 to 1998 with few changes, to 2003 also with few changes, to 2007. Now we get regex, smart pointers, hash tables, to 2011, lambdas everywhere, to 2014, eventually 2017, and beyond. Combining those two contexts, we get more features, but more problems. We're back to the original problem. How are we going to lead our staff to effectively use the new features that are available? We're making modernizations on 11 million line of code base become with technical debt and legacy code that we've amassed over the years that very much becomes turning the oil tanker for us. Obviously, we're speaking to our own applications and to our own contexts, but and we're sure that you face other challenges. This is a fuzzy subject. Few right answers, but we sincerely hope you get value out of our own personal case study. In putting together this talk, we tried to group our experiences into different classifications of how we try to provide leadership. For many of you, none of this will be surprising information, and honestly, none of this is earth-shattering. It's likely you're going to hear a lot of this, a lot of what we say, and say, you know, of course. But creating a taxonomy here serves as a useful exercise in thinking about how we go back and to our organizations and lead with C++. We've grouped our experience into 5 different classifications, and we'd like to present them in the abstract around value, along with tangible examples of how we've tried to address them. We hope those tangible examples raise ideas for your own development contexts. John?
Yeah, thank you. Thank you, Kevin. The first section that we chose to break out our presentation is to educate yourself. Educate yourself is probably the most straightforward and the most obvious thing. Obviously, everybody who's here puts in an effort to do this. You've taken the effort to come to CppCon, you try to stay current, and you're aware of the movement and the committee and the new ISO, what they do with the ISO. So this is a bit of preaching to the choir. Keep your personal knowledge current, stay current. We're on the Microsoft stack. Microsoft has a wonderful video magazine on their Channel 9 that we frequent to get information on the tool chain that we use. Also, attending convention. If you can't attend convention, the YouTube CppCon videos have proved to be a great reference and a great source of information for our development staff. And Reddit RCPP is also a fabulous source of information. You don't have to be a key contributor to frequent Reddit RCPP. Kevin and I are more of lurkers, but there is a tremendous amount of information there that we find valuable. Keeping yourself current is the first step in keeping your development organization current. That seems very obvious, but current leadership makes for a current organization. And having current leadership is the first step to making good design decisions for the short term as well as for the long term. But your education cannot be in a vacuum. What we learn means much more if the information is shared across our development staff. How do we accomplish that? What are the steps that we take to ensure that information that we gather is disseminated amongst our staff? Our tangible example is going to be our attendance of this conference. This conference provides access to the luminaries of the C++ community. What do we do with that access? What do we do with that information? How do we gather that and bring it back to our people? How do we use this to our organization's advantage? The first thing that we did is we spread word to senior and leadership amongst our developers about attendance. We use that and we ask for input regarding session attendance. We circulate the list of sessions. Perhaps there's something that they have seen something about, something that they think could be of value to our development organization down the line. And even if there is no input from the senior and lead developers, you still raise topic awareness. They've still read session descriptions. They've still seen what's going on. Awareness is a very, very valuable thing in a development organization. Then how do we bring this home? When we were at CppCon last year, Kevin and I, this is a question that we asked each other. How are we going to use this to the advantage, not to our advantage, but to the advantage of our development organization? And we came up with a semi-formal trip report. Trip report has parameters. We need to have a section and include information for each topic that we attend. We have to look at the topic in the short term and the long term. Is this something that we should allocate resources for immediately on our staff? Is this something that will never map to our space, but is just cool? And we also, when we're divvying up sessions, we put in a concerted effort to not attend the same sessions. There's going to be about 20 blocks when we're here for us to see sessions. And if we go to the same sessions, we'll see 20 things. And if we go to different sessions, we'll see 40 things. Keynotes withstanding, it's going to be a little less than that. And then when we return, the trip report is presented to the lead programmers in our regular lead programmer meeting. We talk about each session, we talk about things that we find valuable and things that might be more of a long-term interest to our organization. It also serves a second purpose in that our leads meeting is recorded, it has notes, and it's made publicly available, or not publicly available, but it's available internally to our entire development staff for the spreading of information.
Thanks. In addition to technical leaders carrying this information back to the organization, there's also a need for all developers to feel responsible for their own education and creating a development culture and support of that. We live in a world where access to computing educational resources is available to anyone with an internet connection. The biggest challenge can be awareness across a group, particularly around junior or tenured staff. We also have challenges on applying the knowledge. how to map the knowledge gained around modern C++ into our application domain. It's easy enough for all of our developers to see immediate value in range-based for loops, but for a lot of developers, for techniques like SFNAE, not so much. Creating a culture around self-education has an appeal to our management as well, as it's a low-cost solution that allows self-motivated people to get individual specialties as they're interested. It also helps keep our developers engaged. More engaged developers equals increased staff retention equals higher quality product. So what have we implemented to create a culture around self-education, and how does it relate to modern C++? First off, whatever we do, we have to be respectful of our business and release cycle, which for us is yearly. We're in an industry where missing our shipping deadlines means that we're out of business. While that's tough, what's nice about that is we have a good understanding of when we're going to be in crunch time and when we're not, because it can't all be crunch time. So a few ways that we've been effective at using that cycle around our culture has been taking a weekly meeting of the technical leads, which is mostly around discussion of the business needs for the release cycle and things like that. During our natural yearly downtime, we have the ability to repurpose that meeting as a place to educate each other or bring in staff to present any work on interesting side projects. This has worked well for us because everybody's already got a time commitment for it, and it doesn't require extra coordination around scheduling. It is essential that we have this meeting held in an open and transparent manner. We very much like transparency. One thing we did to some good effect was dole out micro assignments during this downtime. We assigned pairs of developers, leads and juniors, video reviews. This is a small time commitment for the developers to watch an hour or hour and a half lecture and present a report at our weekly leads meeting on their findings and what they feel is relevance to our day-to-day work, if any. CppCon's YouTube channel, Microsoft's Build Conference were excellent resources here. We've reaped benefit from this in the self-education culture, like promoting the use of auto, readability through range-based for loops, better and more consistent container usage, like preferring std vector in almost all cases, and solving more problems with our AII. More of a macro assignment during this downtime is review of our tooling, compiler versions, and library versions. Especially around compiler versions, as new C++ features are available, we've tried to coordinate the migration efforts with some pushes of the developers working on this to do exploration and self-education. For example, as a std initializer list became supported by our compiler, the developers doing the compiler migration refactored some old mutable containers that used individual element insert into const containers with a construction std initializer list parameter in places where we really could use a const container for better code quality. We have found that self-education does break down sometimes in that advanced concepts aren't always easily mapped to your problem space, even when they can be effective. We've had a few occasions to try to spread the knowledge around more virally by starting developers off on a implementation. As an example, SFNAE or enable if compile time techniques can be seen as interesting mental exercises, but not necessarily part of our application domain. Over the past year, we had a need to JSON serialize deep collections of arbitrary data types, all known at compile time. Rather than solve that using a brittle custom solution or RTTI, we let the compiler do the heavy lifting and figure out the JSON structure for us at compile time via SFNAE, enable if template functions that were enabled against container type. We found that this was not only an effective way to solve the problem, but it served as a way to drive the utility of this technique home, showing that it is actually relevant to us. Junior developers involved in this project now have another tool for approaching problems. But just like the first section, this is not complete until knowledge is shared with the rest of the staff. John?
Thank you, Kevin. The next one is going to be another one that sounds very straightforward. Encourage use of best practices. Use of best practices, as we're talking about it here, extends from more code-based things to talk about just as much as process-based things. Things that help to align the solution space with problem space. Make sure that the developers know the correct tools for solving recurring problems inside of our domain space, and make sure that they understand them so that they can map the next set of solutions to the problems. It also creates a staff that is self-sufficient, people who are capable of answering their own problems, and it helps to produce staff that is self-starters. Having similar problems solved in similar way by all developers makes for easier development. It makes it easier for developers to switch tasks. It makes it easier for developers to get spun up on somebody else's work, and it also lowers the cost of onboarding new developers. The next section that we've placed here is your style guide. If you want to watch a wonderful video on style guide, you can watch the CppCon 14 video. I'm not going to go too in depth on it. Sufficient to say that we find the style guide to be a very valuable resource of ours. Our first step was to adopt style guide. We started with the Google Style Guide. It's probably everybody's favorite place to start, but it doesn't always map directly to what you try to do inside of your organization. So our second step was to make the style guide your own. That required a lot of pruning. It required a lot of adding things, but we felt like we streamlined it and made it map to our specific problem space, our API, and our approach to our industry problems. And the third is to make your style guide a continuing conversation. When our style guide was released, we released it in a way that made it very clear that it was not a voice on a hill coming down to the people. It is not written in stone. It's written in bits, and that makes it a continuing conversation amongst our whole development staff. Everybody has access. Everybody has access to new suggestions for things to remove, for things to add, for modifications to specific items inside of it. This is done in a public way, and it is a conversation that involves all of development. And lastly, refactoring across our 11 million lines of code was difficult. It was very difficult. Most developers don't have the entire code base local to their machine. It doesn't make sense. Most people work in very specific areas. So if you want to search across the whole code base, what was our solution? Our solution was a network share of the entire code base on it and brute force searches against it. That was a deterrent to doing due diligence on large code changes, and it led to problems across our development groups. We did it with brute force until we got on the Open Grok train. Now the same searches that were taking minutes with the brute force are handled on a VM that's supplied to us by our DevOps team and are in the order of a second. Our last section is email, where good information goes to die. There's plenty of stories about people, either your Outlook group's retention policy, removing something that you wanted to use, having to maintain a local set of PSTs of information, not CCing the right people on an email, and it also makes it difficult. It's counterproductive to the transparency that we seek. So explore email alternatives. We use an internal social media site for critical conversations, a place where everybody is implicitly included and has a voice to contribute to a solution. We also have wiki for documenting endpoints and things that we use, usually very technical things that don't shift. Critical decisions in our group must be transparent and publicly documented. This raises awareness and spurs conversation in our development group.
Thanks. As a doppelganger to the previous section, we also try to prevent the creation of fragile solutions. Fragile code can be a maintenance or debugging nightmare, and frequently not just for the author, but for others working around that code. Code that utilizes bad libraries or aspects of libraries that prove to be buggy can be just as much of a nightmare. A goal is to create a development environment where there are less wrong options for developers, but things are not done after the failure case is reached. We like to provide direction at the time and place of failure to improve efficiency. We'd like to go over a few examples of where we've tried to limit these worst practices. The language has advanced significantly around the lifetime of our application. Std autoputter was awesome in 1998, but that shouldn't be used now because of subtle ownership issues. So how can we prevent the use of std autopointer? Some of our code is over 20 years old. How can we prevent namespace pollution from .h files. Boost is wonderful. Microsoft STUD implementation is wonderful, but we've had issues with individual parts of those libraries. How do we protect our staff against using those parts? We found it effective to stop this with our style guide requiring a set of header files to be used universally in all of our CPP at H files at specific relative positions, and providing some enforcement in those headers with, that those standards are followed. Admittedly, this is not perfect, but works with our build process to allow us to inject our code around the library level and either deprecate, static assert, or completely disable components that are problematic for us. Static assert has also been particularly useful for us when combined with type traits to make sure some template libraries that we've used, that we've developed, are getting the right kind of T. When the template libraries are passed incorrect T parameters instead of kind of sort of working or generating incomprehensible error messages, we'll catch it early at build time with a decent error message that shows the developer exactly what they've done that's wrong. This really requires a good feedback loop across our organization so that as consumers of the library experience problems, they'll be able to assist in getting those problems caught with new compile time guards. We want our developers to be alerted quickly when going down the wrong path. When possible, we like to catch those worst practices at build time. Fail fast is a term that you hear a lot working in development. Effective static asserts make it possible to fail really fast. We like catching problems before code leaves a developer's machine. When combined with a good CI build process, it also keeps your source tree good for other developers. We personally get a lot of added benefit out of Microsoft's team build, gated builds, and the enforcement policies. When a gated build fails, the check-in is not allowed into the source branch. This failure also includes failing any of the unit tests. There are places that have traditions of shunning a developer that breaks the building of the tip. And while this sounds fun, I'd rather have a guarantee that the tip builds and development can stay productive. Sometimes, unfortunately, we do have to amass some technical debt in our code. Like we said before, some libraries may have aspects that are less than desired. Sometimes compiler language features are incomplete. We may want to use the library or the compiler feature as the real solution, but when we can't, they force homebrew solutions. We recognize that as being a short or medium-term technical debt, maybe on the year or 2-year level. We choose to own a lot of that technical debt through static asserts against external attributes like library and compiler versions. We do this with a lot of caution because this can be pretty dangerous. Our admittedly maybe not best practice is to make sure that we have a reasonably tested solution using a newer compiler or alternate standards conforming compiler where we can test the preferred solution and then include that as comments around the static assert. We're very cautious when writing code like that because it requires a drop-in replacement when the external attributes change.
Thank you. And our final section is leadership through API. This is about as direct as it gets for raising awareness of different techniques and approaches. How do we lead through API? Why use API? Like I mentioned, it's incredibly direct, and I'm going to tell you that this is for internal consumers. This is for people inside of our development organization. These are not published or third-party APIs. These are ones that affect only our staff. The consumers are forced to deal with or understand new approaches, new parameter types, and new return types directly inside their code. It is directly pushing knowledge to their workspace. The downside of it is that any responsible API owner is on the hook for documentation, and no self-respecting programmer likes writing documentation. Changes have varying degrees of how they affect the developer. It can go from, here we have, this is directly from our code base, foo and bar. The old pattern of passing a foo pointer or foo reference and getting the reference back for populating a large object. That's still functional. It's not always best practice. Now with move operators, it makes a lot more sense to use the foo bar that's listed below for passing information of move semantics and getting developers comfortable with using them and aware of them. And the second selection that we chose from our code base of the second example of this is we have old code that takes function pointers as a parameter, as a callback. has a number of problems that any programmer can, any seasoned programmer can identify. We have to pass information in via global state. Those are all no-nos in modern C++. We have refactored those API calls from taking a function pointer to using std function initialized with lambda functions. By doing this, you are increasing awareness across your development staff, not only of lambda and capture, but of the importance of avoiding manipulating and using global state. Kevin?
Yeah, thanks. Staying current is an increasing need in modern development. As modern C++ continues its aggressive velocity, it will only become a bigger need. There's no single correct approach for this. Every development organization will have its own needs to respond to and its own culture to create. Our goal here today was to increase awareness and present our own way of thinking about these problems. Thanks very much.
Kevin, questions?
You were taking std function in the previous slide. Why not use universal reference?
Because we had to go across API bound. Yeah, we had to go across API boundary. Oh, I'm sorry. Repeat the question. He asked why we were taking std function in that last example and not taking a universal reference. And the answer was that we had to go across a DLL boundary. So, yes.
This is a really narrow. This is a really narrow question, and I don't mind if you just say, like, come talk to me afterward. But you mentioned something about using sphinx in a context of parsing JSON, and that's dear to my heart. I want to know what you're talking about there.
Oh, it was a sphinx in generating JSON from a C++ object model, and I can talk to you about that. So, yes.
Can you talk a little bit more about how you use static asserts to help keep your code base? You mentioned a little bit on the slides, but it's a little abstract. I'm not sure what you were describing.
Well, we have for static asserts to help keep our code base maintained well. We have some libraries that were that were based on a T parameter of being a pod that could be a memcopied structure, or also there's versions of that actually support their own serialization where memcopy couldn't work, and so we were using static assert around the various T that was coming in to be able to and checking that at the point in time of instantiation of the template to allow the programmer to better know that in case they're using the wrong kind. Yeah.
Just one follow-up question. Was there something about particular T values that would be relevant to modern C++, something that would only work with C++ 11 or 14?
I don't think that there was anything. I think that the static assert would be more of the example right there. Okay. I think that we've got to get out for. Are you next? All right.
All right.
Thanks very much.
Thank you for your time. We appreciate it.
All right.